coordinate systems. So when it comes to coordinate systems, there is this thing called handedness. So coordinate systems have a handedness. It can be a right-handed system or a left-handed system. And in the case of right-handed system, like where does this why is it handedness and why is it right-handedness? So if you take your hand and you place it like it's on the figure, so you spread out your like thumb and index finger, and your middle finger is pointing this way, then your thumb is going to point at the first basis vector. Your index finger is going to point at the second basis vector, and your middle finger is going to point at the third basis vector. So this is a right-handed system. And if you do the same with your left hand, you see that these things are different. If you try to match the first axis and the second axis, then the third axis is going to point towards another direction. So they're distinct, a right-handed system and a left-handed system. In computer graphics, we often use a right-handed system, but there are of course instances where we also use a left-handed system. So there is this very cool illustration here that, here, have a coordinate system chart. So in OpenShell and Blender and Source Engine, CryEngine and Maya, a right-handed coordinate system is used. Although what is up, like is Y up or is Z up, that's different. But in Unity, DirectX and Unreal, a left-handed coordinate system is used. So this kind of creates a few problems when you move 3D models from Blender to, let's say, Unreal. But just so you know that if something is off, it might be that your coordinate system is with a different handedness, or that the direction of up is different. So what does this handedness affect more than just where does the third axis point towards? One thing it affects is the positive angular direction. So in a right-handed coordinate system, the positive angular direction is counterclockwise. So it's basically like if you look at the third axis, so the third axis is pointing towards you, then the direction from the first to the second basis vector is the direction. So like this, the third axis is pointing towards you, and if you move from the first basis vector to the second, so this is this counterclockwise direction, and that is the positive angular direction. If you try to do the same with like a left hand, well, this gives you a clockwise angular direction. Now this also defines something interesting. So if we have triangles or any polygons, then the order in which its vertices are when facing towards you or towards the camera as we use in computer graphics, then that defines kind of two sides of a triangle. So there's like a front side and a back side, or a front face and a back face. So in a right-handed coordinate system, if you look at a triangle and the order of the vertices is counterclockwise, then the triangle is facing you. But if you look at the triangle and the order of the vertices would read clockwise, then the triangle is facing away. And if you have this like 3D imagination, you can imagine a triangle that is facing you, and now if it rotates 180 degrees, then from your point of view, did the order of the vertices change? And if you don't have this imagination, you can take a piece of paper, cut out the triangle, write on the corners ABC, other side as well, that they match, and then you see like if you read ABC, is this a clockwise orientation? And if you turn it around, is it now also clockwise or counterclockwise? And you can play around with this. But just remember that triangles have two sides or two faces, a back face and a front face, and this is actually very useful and comes into play later on in computer graphics. Another interesting thing that the handedness affects is the cross product. So if we take like a left-handed system and we have vectors u and v, and we are finding a cross product between u and v in that order, then we could like take our left hand, so u is the first vector, v is the second vector, so the result is going to point that way. If we're looking at it like this way, then it's gonna point away from us. Similarly, in a right-handed system, if u is the first vector and v is the second one, like on the picture, then the cross product is gonna point towards us. It always points towards us if the order of the operands is in the positive rotational or angular direction. And you can kind of play around with this. And you can also think about things like bottle caps that you turn to open a bottle. So if you turn them counterclockwise, then they move towards you. If you turn them clockwise, then they move away from you. So if you think about it, and I'll leave this as homework, so in which handed system are we living in? These bottle caps and screws and all sorts of things, in which handedness have they been designed? Are they in a right-handed system or a left-handed system? And then you can figure out, like, are we living in a left-handed system or a right-handed system? And it could be either one, because this is what humans have decided, that if you turn it this way, it needs to go that way. And we all know which way it goes, but yeah, you can think about it like, is it right-handed or left-handed? So from this video, you should now understand the different handednesses of coordinate systems. You can envision a left-handed and a right-handed system. You can determine the handedness of a given system. So if someone gives you like, this is X, this is Y, this is Z, you should be able to tell, is it a left-handed system or a right-handed system? You should understand the positive angular direction, in a left-handed system it's clockwise, in a right-handed system it's counterclockwise. That there are different faces of polygons, a front face and a back face, and well, we can specify like for triangles, because if you have more vertices, they could be defined in some weird order. They might not be just defined like in the circular order around the polygon. But for triangles, it's simple to know that there's only two choices, like they're going either one way around or the other way around. And depending on the handedness of the system and which way these vertices go around the triangle, from your point of view, that tells you, are you looking at the front or back face of a triangle? And this handedness also affects the cross product's result direction. So if you turn a bottle cap, which way does it go? Think about it.